So next I'll going to tell you about the all formulas related to the three phase connection. Okay, so in the three phase connection, as you already know, that it is further divided into two category. One of the connection is star connection, another of the connection is delta connection. In the star connection, the diagram is like this. This one is R, Y, B, and in the delta connection diagram looks like this. Like this would be R connection, Y connection, B connection. RYB means red, yellow, blue. So this in this will have neutral, but in delta we don't have neutral. Got it? Now in the star connection we'll have relationship, that is line current would be equal to the phase current. Now what is line current? The current which is flowing in the wire, plain wire, like IR, IY and IB. These are the line currents. IR, IY and IB. These are flowing in the plain wire, so these are the line current. Now phase current is which is flowing across the winding. Phase means a winding, you can understood like that. So in this INR flowing, in this INY flowing, and in this INB is flowing. So basically the current which is across the winding, that is known as phase current. So both currents are equal. Okay. Now the next relationship is VL is equal to root 3 VPH, that is line voltage must be equal to root 3 times of phase voltage. What is line voltage over here? The voltage between the plane line VRY, VYB and VBR. Correct? Okay. These are the line voltage VRY, VBR and VYB. Now we need to mark the phase voltage. Phase voltage is across again the winding, that is VNR, VNB and VNY. So we don't have equal relationship, but we'll have relationship that line voltage would be equal to root 3 times of phase voltage. Similarly, if we'll connect to the delta, we'll have IR, IY and IB. These are the line currents. Like suppose this is 1, 2 and 3. So IR, IY and IB. These are the line current. I13, I12 and I23. These are the phase current, right? Because it is in this current is flowing across the winding. So what is the relationship between line current and phase current in delta? That is IL is equal to root 3 of IPH, correct? But in this case voltage is equal, so you need to remember only one thing, what, that in the star connection if current is equal, if current is equal then obviously voltage is different. And in the star connection if current is equal then voltage would be same. In delta opposite, it goes opposite. Okay, in the star connection voltage is different, but in the delta connection voltage is same. In the star connection current is same, but in the delta connection current is different. Okay, star and delta are complementary to each other. Understood this point? Now we'll have need to calculate generally the three types of power. Active power, that is P, and its formula is root 3 VL IL cos phi, or we can say 3 VPH IPH cos phi. And its unit is what? You should remember the units because in the question they'll give you direct the units. Okay, this is known as active power. Similarly, we'll have reactive power. Reactive power is denoted by Q, and its formula is root 3 VL IL sine phi, or we can say 3 VPH IPH sine phi. Okay, and its unit is VAR. VAR means volt ampere reactive. You have to remember the unit as well. Next one last is the apparent power. Apparent power is root 3 VLIL, or we can say 3 VPH IPH. Both the formulas you can use, that is totally depend on you which formula you want to use. Okay, and its unit is VA. VA stands for volt ampere. This power is known as apparent power. Now some of the students got confused that whether this power is for star and delta. So answer is this power is for star as well as for delta. Okay. So we'll have the same formula for star and we'll have the same formula for delta. Power is same for both the cases. Understood? Hmm? Now the next formula came across with you, that is most important again, by the 2 wattmeter method. Remember 2 wattmeter method. So total power consumed is W1 plus W2, and if we want to calculate cos phi, cos of, what was the formula? Cos of tan inverse root 3 of W1 minus W2, actually in your handbook. Okay, I'm moving according to your handbook. W2 minus W1 or W2 plus W1. Okay, so you have to remember this formula as well. And power will have again the same formula, root 3 VL IL cos phi. And sometimes you need to calculate W1. W1 is VL IL cos of 30 plus phi. Okay, and W2 is also equal to VL IL cos of 30 minus phi. These formulas are according to your handbook. अगर तुम बुक्स में देखोगे तो ये फॉर्मूला थोड़ा सा चेंज है, वो W1 माइनस W2 है, बिकॉज यहाँ पे भी उनकी वैल्यू चेंज कर दी. बट आई एम नॉट टेलिंग यू अकॉर्डिंग टू बुक, आई एम टेलिंग यू अकॉर्डिंग टू मणिपाल हैंडबुक. ठीक है? So you don't need to remember this formula because this is already given in your handbook, but you should know that where we need to apply. So one of the question will definitely come from either star or delta, 100% sure, or maybe another question get it for you will get it from the 2 wattmeter method. This is I'm saying that 90% chance, because every time you will get two questions in Manipal based on this, right? One based on star and delta or this one, and it is of 10 marks. See, it is of complete 10 marks. If you score in this, then you won't be able to fail, right? Now this was, I told you, for the balanced load, right? But we'll have different formulas for the unbalanced load. In unbalanced load, as you already know, in the star connection current is same, so not an issue regarding the current, but the voltage is different, right? So voltage is VRY. What I told you, the formula VL is equal to root 3 VPH, right? But if we'll have unbalanced load, then we don't use this formula, we'll use this formula, like VRY is equal to VRN minus VYN. Okay, what is VRY over here? You can see it's the line voltage or the phase voltage. VRY is the line voltage. Very good. Similarly, VRN and VYN, this one is the phase voltage. Correct. So we'll have VYB. VYB is again VYN minus VBN. VBR is equal to VBN minus VRN. So basically, if you will have phase voltage and you want line voltage, then you will convert it like this. Understood? In case of unbalanced load. Okay. Now I'll tell you in this was about the delta connection also. As you know, in delta voltage is same, so we don't need to consider the voltage. I'll tell you about the current, because in delta current is different. For the balanced load this formula we'll use, but for the unbalanced we'll use this formula. IR is equal to IRY minus IBR. I'm moving according to the RYB sequence. Okay. RYB means R, then Y, then B. Now see how will this formula come? IR is equal to RY, right? IRY minus then BR. Similarly, what will have for IY? IY is, it start from Y, so it would be IYB, right? IYB minus, then after B, what will have? R and Y, so it would be minus IRY. Now IB is how much? It start from B, so it would be BR, IBR minus IRY. Sorry, minus IYB, right? Because BR minus YB. Got it? So we'll have these formulas for the unbalanced load. If there is a question of unbalanced load, then you have to look in this formula. It is also mentioned in your handbook. Got it? Now, maybe sometime they will change the sequence in the question. Sometimes they will say that RBY. So accordingly, formula will change. Or sometime they will say 1, 2, 3. Or sometime they will say ABC, right? To confuse the student. So accordingly, you have to change the formulas. Okay. Now the next one is in case of unbalanced load, if there is a connection of RYB, R is like this, Y and B, right? So R and Y will have how much phase difference between this, that is 120 degree. So generally they'll say like voltage is equal to 400. Okay. So as I told you in the sequence, VRY is first of the angle is 0, another angle is minus 120 degree and another angle is plus 120 degree. Okay. पहले 0, then minus 120 degree, then plus 120 degree. इस sequence से याद कर लोगे. VRY is angle 0, VYB is 400 minus 120 degree and VR is 400 plus 120 degree. When we need to consider only in case of unbalanced load. Got it? If there is a balanced load, always consider angle 0. But if there is unbalanced load or they'll mention something like that, so you need to consider the voltage angle also. Got it? You can't take every time 0 in case of unbalanced load. So these are all the formulas.